Hello everyone, welcome to the series of O-Level Mathematics Class 9 1 IGCSE Cambridge syllabus. So as you see in this series, we are doing almost all the concepts that are coming in the paper 1 of Class 9 IGCSE syllabus, and for this we are following Collins Cambridge book. Now our today's topic is the sine rule of which is the exercise 26.9 of the Collins book. So let's start the lecture. Okay, so our today's lecture is sine rule, that how it comes and what is the motivation behind the sine rule. So we know in a triangle we have six measurements, right? Six measurements means in triangle we have three angles. Let's call it alpha, beta, and gamma, right? So these are three angles. For the triangle, we know that alpha plus beta plus gamma equals 180. Okay, so these are three parameters. Other three are the sides, i.e. the sides. So the labeling is really important when we learn about the sines and cosines rule. So in when we have beta, so the side which have come in front of beta, we call it B. The side which is in front of alpha is A, and the side is in front of gamma is C, right? So most of the time in the papers, actually this question comes like in that way, that instead of alpha, beta, gamma, they say, okay, use for the convenience that this is capital, this is capital B, and this one is capital C. So this is small c, right? So in the sine rule or in the cosine rule, this thing really important that you write the same angle and the sides for the labeling of names. Okay, so you can easily see now we have three sides parameter and three angles parameters. These are angles, these are sides. So the law of sines or cosines actually help us to find out these things. Okay, whenever we have given any three parameters, we can find out the other three, right? So thing is that if we have given any three parameters, so any combination, right? So we have three angles and three sides. So total six parameters we have. So given any combination of three parameters, right, you can find other three. Okay, but there is some exception, right? And so you can find other three. So what is that exception? So when you are given all three angles, you can't do find. So you can't find other three things. So then these things are what? Sides, right? So the rule of sine and the rule of cosines help us to find other three parameters when first any three are given, right? So any three of them, so we have alpha, beta, gamma, A, B, C, or you can say now in our new notation, capital A, capital B, capital C as an angle, right? A, B, and C, right? So whenever any combination in which the all not three are angles, right? So if we are given A, B, and C both, all the three, so we can't find these three, right? So always remember that in this case, it is not possible to find out the other three parameters, i.e. other three sides. But if we are given combination like a way that we are given two angles, one side, two angles, so any two angles or any one side, or any two sides or any one angle. So you can find other three as well, right? And how we can find that, we will see. So first of all, let's see the sine rule. What is mean by the sine rule? So let's suppose we have this triangle, right? So this triangle has this point called A, this point called B, this point is called C, and the side in front of this point C is this small c, and the side front of this point A is small a, and likewise B. So let's suppose I draw an perpendicular. So this is perpendicular line, right? So this is perpendicular line and I draw it. So definitely since it is perpendicular, it is straight. So this means that from the base, it makes an angle of 90 degrees. Okay, so now let's do find this h. So we can find this h by using the triangle rule, right? So right angle triangle rule. So now we have two right angle triangle because of this perpendicular, this triangle, right? A, D, and C. Triangle A, D, and C is right angle, right? And likewise, triangle A, D, and B is also right angle because of this perpendicular line, right? So these two are right angle triangles. So it means that from one triangle, when we draw a perpendicular from any point, we got two right angle triangles. Okay, so let's find out this h using this triangle, which is A, B, and D, right? So first using this triangle, let's find out the h. So we know the rule, right? Some people have curly brown hair. Some people have curly brown hair. So we know we find out trigonometric ratios by this phrase. Okay, so it says that sine. So we can use sine of what? So the angle which is opposite to x. So we are finding this h. So we use this point. So sine b, right? Sine theta equals to what? Perpendicular divided by hypotenuse. So what is our perpendicular here? Our perpendicular is h. So the line with the 90 degree, right? So this is h upon hypotenuse. Hypotenuse, the line which is the largest side, right? Which is the largest length. So this is c, right? So it means we can find h by when we take this c to the left hand side. So c is multiplying with this. This is small c with sine beta equals h. So we found out the value of h using this triangle, using triangle A, D, and B. Okay, now let's do the same thing using the triangle again. Same thing. So using triangle, but what this one, which is A, D, and C. Okay, again we apply the same trick. So here what we have to do, so this is now perpendicular. So again sine, perpendicular, and hypotenuse. So this is the point. So in front, the opposite side is this hypotenuse. So we use this sine c equals, again perpendicular is h. Now hypotenuse is, the hypotenuse of this triangle is b. And when we take this b to there, on the left hand side you got sine c, sorry, b multiplied by sine c equals h. So here you got another value of h. It means you got h from this triangle and also the same h from this triangle. So h is same, but you found out by using two different triangles. So it means this h and this h is actually same. So what we can do, we can equate them, right? It means that this thing is equal to h, this thing is equals to h. It means both things are equals. So we write, therefore, this thing we write c sine b, right? C sine b, the left hand side of this and the left hand side of the equals b sine c, right? So what we can do next, that this sine b goes here in the below, right? Because it's multiplying it, it's come here, it divides. Sine c multiplying with b, this goes to the left hand side, it divides. So we got this formula c upon sine c. So please note that whatever angle we have below, the same side we have above. So c over sine c is equal to b over sine. See, we got this formula. Okay, so this is actually the one part of a sine rule, right? The sine rule has other two part as well. Okay, so what these parts are? So first of all, likewise we draw the perpendicular, right? In this triangle, I draw perpendicular from A to the side BC. Now we can draw the triangle instead of A, we can draw triangle from B. But remember that we have to draw the line, this perpendicular line, right? This line in a way that it touches the opposite side, that makes 90 degrees. So that's why by using this trick, we got again two triangles, this one and this is small. So when you solve the same thing that we did from this triangle, we got this a sine a. Again, the side is a, and below it we have the same angle, capital A, and the c sine c, right? So, and when we make this perpendicular from side C, it means from here again we are take care of the fact that it makes 90 degree. So that's why we are not joining it from here, right? Because when I join this C from here, this doesn't make 90 degree, right? This is not 90 degree. So that's why we have to draw a dead line which make a angle 90 degree from the opposite side. Okay. So when you do the same working that we did in a first triangle, so what you got, again this rule, which is a upon sine a equals b upon sine. So actually the sine rule has three parts, part 1, part 2, part 3. Okay, so this is three parts of a sine rule. What the complete sine rule is this. So complete sine rule is this: a is the side divided by sine a, capital A is the angle, equals b upon sine b, equals c upon sine c. So this is the formula. This is the formula for sine rule, in which we combine all the three parts at once. In the same way, we can write the same formula, because we know when we reciprocal the first thing, the second and the third thing can reciprocate automatically. So we can actually write the same formula in a way like this, that angle is above and the side is below, right? So this is also the formula of a sine. So actually sine rule has two variants. So this complete sine rule has two variants. A upon sine A equals B upon sine P equals C upon sine C. Likewise, sine A upon A equals sine B upon B, sine C upon C. Okay, so which formula you have to use in which case, right? So we have two variants, but what we can use in what case? So remember that whenever you have to calculate a side, right? So our motivation is that in a question we are given any triangle in which any three things like angle A and B are given and side like say small a is given. So these three things is given. For example, so what we have to find? The angle C, the small c side and the small b side. These three are left, so we have to find these, right? So when you are finding the unknowns, so these three are unknowns, right? When you are finding the unknowns, if you are finding the angle, right? So use the formula in which angle is above, angle on the top. But when you are finding the side, this is the side, so use the formula in which side is on the top, right? So this is the rule of thumb to solve the sine rule and find out the parameter. So this is the complete theory why we have the sine rule in mathematics, and how we can derive it from the triangle, and how we can use it in the questions. So this is the complete theory.